Hey everyone, and welcome back. In today's session, we'll be taking a deeper dive into the fascinating world of materials. By the end of this video, you should have a solid understanding of the basics of what is known as the PBR, or physically based rendering workflow, to allow us to create versatile, believable, and reusable materials inside of Unreal Engine 5. If you recall from the last video, I mentioned materials briefly. We talked about them in the sense that they are assets that can be applied to static meshes like these in order to make them look like they are made out of something. And this one here, this is a static mesh, and it has a certain material applied to it in order to make it look like a rock with moss on it. This static mesh, however, is first of all, it's a simpler mesh. As you can probably tell, there are a lot more nooks and crannies and details on this mesh compared to this one. But this also has at least one material applied to it that defines the appearance of the metallic, I guess, the outside of the chair and then the cushions. But why are they called meshes in the first place? I did not address that point, and this would be a good time to do it. The reason that they're called meshes is due to the fact that 3D models or 3D objects, when displayed in 3D software, are generally comprised of groupings of polygons. In the case of Unreal Engine and in the majority of modern 3D software, the polygon that is chosen is that of a triangle. Mathematics associated with triangles are, it's simpler math, frankly, compared to using other types of polygons, and triangles are usually sufficient. So we can visualize this if we move our mouse up to the left upper side of the main viewport, where we see this word lit. Lit, by the way, is the default lighting mode in Unreal Engine. So we are in lit mode right now. We're seeing things normally with their shadows and everything looks normal. There are other view modes, though, that are helpful for different types of work. And we can visualize the triangles that make up the meshes in this scene simply by changing from lit mode to something like wireframe mode. And that is 3 down from the top. So I can click that, and you can see here, hopefully, this is a much denser static mesh, but hopefully if you zoom in enough on the chair, you can see that each little part of the chair is a triangle, and their vertices meet, and they can change in terms of their transform properties to give the appearance of a 3D object. And right now I would have to zoom in very close, I suppose, for you to see those triangles here, because there are so many more of them. So this is a much more complex object. I have another way, by the way, to allow you to visualize the triangles of this mesh, but it won't be in this window. I just want to make the point that some meshes are simpler than others. Which one do you think would be more computationally expensive, so to speak, to render? One with fewer triangles or one with more triangles? Well, if you guessed that it would be the one that contains more triangles, you are correct, okay? And the fact of the matter is that sometimes you'll bring in a 3D model that, in fact, has not been optimized and has far more triangles, far too many, compared to what it actually needs to look exactly the same to the naked eye. So that's something that we will address in the future. We don't want to be working in this mode most of the time, so I'm going to go back to where it says wireframe and switch myself back into the default lit mode. If you feel like remembering the keyboard shortcuts, by all means do. So I will use just this lit mode, and we're back to where we started. As I said, both of these are static meshes, and when you have a static mesh in your world, you could click on it, and if you want to inspect that mesh, what you can do is in the Details panel, provided that you have it selected in the Details panel, locate the static mesh thumbnail and double-click that. Double-click. And this will bring up what's called the static mesh editor. And like most of these windows that have a tab like this, they can be docked. So I'm going to dock mine up here. And I can use my normal controls to move around and visualize this from whatever angle I desire. And also, this will obey my camera speed as well. Sorry that shakes a little bit when I manipulate that, but it just does that. Okay, so now I can zoom in and around this chair. So I'm looking at it at a very close distance, and I can see, first of all, I can look where it says triangles, and I can just see a number. That number in this case is 1,782. We'll have to talk about this term nanite in the future, but essentially this model is comprised of 1,782 polygons, all of which are triangles. I can switch from lit mode into wireframe mode and visualize that if I wish, but again, if you were to look at every single part of this wireframe, you will discover that it indeed is a triangle. So we'll go back into lit mode. Now this model has 1,782 polygons, triangles that make up the entire mesh. And I can see that it has, among those triangles, it has made use of 1,467 vertices in order to create the shape and the appearance of this. Now, it is possible to use too many triangles, which is computationally inefficient, and it's also possible to use too few triangles. If we were to use too few, this would not have as smooth an appearance as it does. It might have jagged edges, for example. So there is usually a sweet spot in optimizing the number of triangles that any given mesh is going to use. So let's remember that this one had, 1,782 approximately. Okay, we're going to say somewhere between 1,000 and 2,000 triangles, so you don't have to remember the exact number. Okay, somewhere between 1,000 and 2,000 triangles. Now let's compare that. I'll close the tab, ignore this, and I will select this mesh instead. And just like we did before for the chair, with this mesh selected, I can go to the Details panel and find the thumbnail for it and double-click it. Okay, let's dock this as well, make it easier to look at, and get right up on it. You can see this is far more complex. If we go into wireframe mode, wow, I can't even see the triangles until I really zoom in very, very close. But it has many, many more compared to the chair. The chair had between 1,000 and 2,000 triangles, and this one has 2 million triangles. And it's making use of over 1 million vertices among those triangles. So this is a much more complex object. Let's go back into lit mode, and I'll show you something that I think is true for this mesh. I hope it is, because it's something that I would like for you to know. It's a little trick that is played on the user, that some meshes, like this one, are one-sided. Okay, because if only one side of this mesh is ever going to be visible, why ever render the opposite side if it's never going to be seen? And that is another way of optimizing objects for performance when placed into your project level. So hopefully now you have a good understanding of why they are called static meshes. So knowing that they're comprised of different numbers of triangles, it could be said that this static mesh, the rock, will be more computationally expensive, meaning that it uses more computational resources to render compared to this chair that contains vastly fewer polygons, okay, vastly fewer triangles in this case. So the next thing that we're going to be discussing is materials. And I just wanted to get this part out of the way first so that you understand a little bit more about how static meshes work. So right now I'm going to pause the recording, and when I return, I will start a brand new project, and we are going to make some materials together. So here I go, and I will be right back. Okay, so I'm back and I'm all signed into my Epic account, and I'm here at the Unreal Project browser. Why don't we do this together? Let's all do the same thing. I'm going to click on Games, and as before, I'm going to choose this third-person template. This is very convenient to work with. So in our settings down here, I want to leave this set to Blueprint. Target platform can remain on desktop. The quality preset can be set to maximum, and you should probably include starter content, at least for the time being. I have this defaulted to the directory that I made on my F drive, that solid-state drive that I mentioned in our last video, so that's good. Unless I change it, it's going to remain that way, and we're going to have to come up with a name for the project. So let's call this material practice underscore 001, okay? And notice that I capitalized the first letter of practice. That's just to separate it from the first word without requiring an underscore, and that's okay to do sometimes. So the number is because we might practice materials again in a different way. And there's a lot to know about materials, believe me, but today we're going to cover the most important aspects. So I think I've got everything set up. Yes, third person, blueprint, desktop, maximum quality, starter content is on, ray tracing is off, correct hard drive, and I've named my project. So let's hit create. And this should not take very much time to load up. Yours shouldn't either, by the way. So if you're still having long load times, perhaps talk to me separately about that, and we'll see if we can resolve that problem for you. Okay, so this is just a new third-person project, and the first thing that I usually do is I go up to the Window menu, and I load the layout that I prefer, which, as I said before, is the UE4 Classic layout. So we'll just click that, and now this is set up the way that I like, with all my panels, or these aren't all the panels in Unreal Engine, not by a long shot, but the ones that I want visible to me most of the time, they are where I expect them to be. So let's together now navigate back to the Content folder in our Content browser. So we'll go back just by clicking on the word Content. Now I want to make a new folder in this base directory, in the Content directory. Making new folders is easy. You simply have to find some blank space and right-click, and it's staring us right in the face right here, New Folder. When you click that, you use your left mouse button to click it. It will give you the opportunity to rename it. Okay, so I'm going to rename it My Materials. Okay, My Materials. That makes sense to me. Maybe you can use the same name. Okay, just make sure that you name it something that makes sense to you. Now to get inside that folder, all we have to do is double click. And now we're going to make our first basic material together. So in this empty area, I can now right-click, and I want to create a new asset. In this case, under Create Basic Asset, what I will use is this one, Material. Okay? And I'm going to have to name that as well. Usually materials, when they are named, there's a convention for it. They begin with M, capital M, underscore, and that indicates that this is a material, okay? We just have to come up with a name for it. So if I knew in advance how I was going to be using this material, let's say it was going to be a stucco wall or something like that, I might call it M_stucco. Or if it was a material that was supposed to look like brick, I might call it M_brick. But right now we're just going to be doing some experimentation. So I'm going to call this one M_demo. Okay, so now I've got it, and you can see that the asterisk is there because it has been created but not saved. So I'll highlight that and Control S, and now that has been saved. Now we've got some work to do because this is an empty material and doesn't look like anything. So we'll double click it, and that will bring up this material editor. And as I've said before, easy to dock. Okay? Now if you right click in the graph, you can grab it and move it around. You can also use your center scroll wheel to zoom out or to zoom in. And this is important because materials can have a lot of complexity to them. Let me just show you an example, even with one of the starter content materials. So this is just the stuff that comes with Unreal Engine. So for instance, let's look at this M_ground_grass. I didn't make this material. It's one that comes with Unreal. But I'm going to double click it anyway, and you can see that there's much more going on here than just one single node. And all of these boxes are called nodes, and we're going to have to get used to working with nodes in many, many different areas of Unreal Engine. These nodes are relevant to making materials. Other types of nodes are relevant to scripting and programming game logic. So right now we're going to be using the nodes that are relevant to materials. But it's easy to get bogged down in the weeds, which is why it's useful to have that center scroll wheel. And don't forget you use your right mouse button to move this grid view around. Now I didn't change anything here, so I can safely close that without needing to resave it. When you make a brand new material, it will come with this node only. That's what will appear there. And this is called the result node, And certain things have to plug into these various pins. We're not going to go over all of them today, but we will go over several. The first pin is labeled base color. And base color is sometimes also referred to as albedo, A-L-B-E-D-O. And that defines the basic color of the material that you are making. Now, that can literally just be a solid color, and I would like to show you how to do that first. You may know from learning this in another context that colors have RGB values, red, green, blue values. And depending on how those values are combined, their relative values can produce other shades, other colors, other hues, etc. So that, in the context of materials, is called a constant 3 vector. In order to get that, to get the node that I need to define the RGB values, one way to do it is to right-click in the material graph and search for constant 3. And by the way, when you're searching for nodes, very, very often, it is a little bit smart because as soon as it starts to suspect what you're looking for, it starts to present those options for you. So what I want here is a constant 3 vector, okay? So it can be that one. And you'll notice that there are 3 primary parameters here, x, y, and z, because essentially it is a type of coordinate system. So x refers to the value for red, and the range is 0 through 1. Same for y. 0 through 1, and same for z, 0 through 1. Notice here that the color is black. If I wanted this to be white, that would be a value of 1 for each of these above. Okay, now I have white. So 111 is white, 000 is black. What if I wanted to make just red, plain old red? Well, I remember the order, RGB, red, green, blue. I can leave red set to 1, and I could take the green value, set that to 0, and set the blue value also to 0. And now I have red. Furthermore, you can double-click a constant 3 vector node, and you can adjust other things here. I can set my RGB values. I can set things like saturation and other things. I can use the color wheel to define a color. You can see as I do that, it's adjusting my RGB values according to the color that I desire. So for now, let's just be 100% red, 0% green, and 0% blue. So I've got just red. And I'll hit OK. If I take this top pin, this is the RGB output, the combination of all 3 of these coordinates, and I plug that into base color on the result node, well, I've just created our first material. It's simply something that is red. If I hit apply and save, now I can use this asset as a material if I apply it to any static mesh. So let's go back to our third-person map, and we'll navigate back into our content directory where we made the folder My Materials. Let's open that up by double-clicking it, and now we can see m_demo, which at the moment is just something that is red. So let's zoom in on one of these cubes, for instance, which is a simple static mesh, and I will just simply drag my material onto it, and there it is. It's now red in color. Likewise, I could have done this in a different way, you may recall. If I simply select either within the world or within the world outliner here, any given static mesh, like that one, notice that there is in the details panel a material element slot. So I could either drag the material right onto the mesh, or I can drag it right here into the material element, and I will get the exact same result. Okay? So let's just make all 3 of the cubes that color. All right? And of course, anything else that I want it to be this color, that would work as well. I'll hit undo to change that. Okay? So this applies to static meshes and sometimes skeletal meshes as well. Many skeletal meshes have parts to them, and therefore they might have more than one material element, and you might have to use multiple materials on a skeletal mesh for their different parts, but we're going to cover that in a future lesson. Now I want to talk about modifying certain aspects of this material, and I have left it docked just for convenience, so I can really easily get back there. Now, this is a PBR workflow, physically based rendering, and this is an approach to creating materials based on how light interacts with objects in the real world. So for example, if I wanted this to be something that is red but looks like it's made out of metal, I've got a metallic value. There's a pin on the result node that I can enter a value. Now the metallic parameter in the result node, I think it has a default value of 0.5. But what I can do is I can control that using another constant. So I want a constant that is just a single float value. So when I refer to a float value, that refers to any number that can have decimal places, as opposed to integers that are just whole numbers. Okay? So I want to create a constant that is nothing more than a single valued float value. All right? So again, we can do that just by right-clicking, and I can search for constant, and just a plain old constant. That's it. Okay? If I use a constant, this value is a float. You can see there is a 0, and then there's a decimal place, and then there's a 0. Okay, the range for metallic goes from 0 to 1, as do many things in development software, computer software development software, and programming languages and value ranges and so forth. That is common. It's not universal, but it is common. So let's plug this in to the metallic input. And we'll leave the value set at 0, and I will hit apply and save. Okay? And we should not see much of a difference now in our cubes, even though they have that material, and even though I just set a constant into the metallic pin. But the closer I get to a value of 1, and I'm just going to enter that value, 1, which is the maximum, it starts to take on more of a metallic appearance. It's not yet as metallic looking as it will eventually be, but when we look at this in the scene, it kind of looks like these could be made out of a type of metal that is just colored red. Now we can control this further. We have this parameter called specular, and that determines how shiny an object is. So I need another constant, a single float constant. When it comes to creating constants, by the way, and you're doing so very often in materials, there is a handy shortcut to know. If I need a single constant that's just a single float value, I can hold down the number 1 on my alphanumeric keyboard and just left-click my mouse. If I need a 2-value constant, I can hold down the number 2, and now I get a 2-value constant. If I need a constant 3 vector, I can hold down 3, and so on. Okay, so that's going to be the method that I'll be using going forward. So how shiny do we want this to be? So I want to control that with another simple constant, so I'll hold down 1 and left-click. And I can plug that into specular, and it defaults to a value of 0. So if I apply and save, nothing changes because it is not shiny at all. Remember, the value goes from 0 to 1, and if I set this value to 1, it's now going to be as shiny as it can be. Okay? And let me apply that. Okay? Now there's one other parameter here that affects the metallic appearance of this, and that is this roughness parameter. If I have something that is rough, it is comprised of a non-smooth surface, and among the nooks and crannies, and here's a big word, the interstices, the spaces in between those nooks and crannies, that will prevent light from reflecting off of that surface in an ideal way. So sometimes we want things to appear rough and therefore not reflect as much light. Other times we want them to reflect more light. In this case, I want this to look more metallic. So I have to get yet another constant to control how rough this material is. So I'll hold down 1, as I did before. And let's just for fun, we'll set this to 1 before I connected. So that means it's as rough as it can be. And I'll plug that into our roughness. Okay? If I apply and save, we will still see no change. Okay? Because it's as metallic and shiny as it can be for a roughness value of 1. But what if the roughness value was in fact 0? I can change that. And now, frankly, it looks a little bit like a globe that you might put up on a tree. But it's not either or. You don't have to be a value of 1 or 0. You could just be closer to one than the other and dial it in according to your preferences. If I have a node selected, any constant node, I can enter the values directly in these input boxes or over here in the details panel. So I've got my roughness highlighted, and let's just experiment with that a little. Let's try 0.2, enter. And you can see that that's a little less reflective. How about 0.1? Okay, that still looks a little too shiny. How about 0.125? Or how about 0.25? We can keep messing with that until we find our preferred appearance. So now that this is metal, I could even change the color. For example, let's say I don't want this to be red metal. Let's say I want it to be blue metal. I can change that. Okay. And now I've got a blue metal material. Or I can make this any color that I choose. So maybe something. Now, I want you to know this about me. I'm badly colorblind, so this is not my forte, color. But I can choose something that's more, I think this is yellow, more gold-like. I can't really tell. But I know that it is changing colors. So for a person like me, what I would look up the RGB values or the hex values for the color of gold, and I would simply input those values. But if you're color sighted, you can just do it by vision, okay, and make your artistic choice that way. So what if this was just fully green metal? Do we like green metal? I don't know. Maybe we like something more purple. Try to blend these values together. Okay, so here we've got a pretty cool material, all right? And we've controlled how metallic it is, how specular or shiny it is, and its roughness. And by manipulating these constants, we can change the appearance of the material, okay? So this is one simple way of making a material, and instead of hitting compile and save, we simply hit apply and save once we are finished. So now you can see, since that material was already applied to those 3 static meshes, it has updated. And again, I can just plop that onto anything that is a static mesh, and you can see it will now appear to be made from that material. So that is a simple example of a material, and I'm going to pause the video now, and while I have this paused, why don't you take a little bit of time and experiment with those constants and reproduce something like what I have here. So when I pause the video, I'm going to leave this material open so that you can refer to it. So I'll be right back. Have fun. Okay, I hope you enjoyed your experimentation with that simple material that you made, and congratulations if you've got it looking cool on various meshes that are in your level. I'm going to remove the application of that material here on these cubes. I suppose I could leave it, but what I'll do is I'll use this reset arrow, okay, and set it back to its default material on all 3, because we're going to now step up our material making skills. So we don't always want something to just be a certain color or a certain reflectiveness or whatnot. Sometimes I need an object to look like it is literally made out of something from the real world. So let's apply this idea to something like a brick wall. To make a brick wall, what we'll do is this. I'll go back to my content directory, and please do follow along with me. Inside of starter content, we have a folder called architecture. Now we could use that. We could use one of these pre-made walls if we wanted to, but an even better way, in my opinion, to create a wall is to simply go into shapes, okay, right here, okay? And we've got a simple cube that I can drag into the level. Now I can use my scaling tool to make something that is more wall-like. I think that's a little too thick, so I'm going to scale it in like so. And there we've got something that is a little bit more like a wall. By the way, if I want to make everything bigger at the same time, I've got a couple of choices. I can use the scale in the details panel. While I've got that mesh selected, I can use the scale parameter. I can edit the 3 axes independently if I want, If I wanted this to be a square, for example, I should make all of these the same value. Perhaps without not including, in this particular case, what axis is that? The x-axis, okay? So I might as well make these the same, 3.75 and 3.75. Okay. So now, and I hope you understand, I referenced my little legend down here so I understood not to change the x-axis, because the x-axis would have just made it thicker, okay? And I want this to be more like a wall. Okay, so what we're going to do for this is as follows. I want to point something out, first of all, in starter content with the brick material that is included. So let's go find the starter content in the materials folder and choose one of these brick materials that comes for free. So I think I'm going to use this one called m_brick_clay_old, and I'm just going to simply drag that on top of the mesh. That doesn't look terrible, right? It looks like it's made out of brick. Interesting. And by the way, if we look at the material, again, there's a lot of stuff going on there to make it look as good as it looks. By the way, we can close this tab if we want to. Looks like I didn't save it. Okay, but I want to just show off a particular flaw in how these materials behave when you rescale the meshes. If I wanted to apply that same material on a different mesh, you can see the scale of it does not remain the same. And if I select this mesh and try to scale it, because I don't like the size that it is, it will deform the scaling that I want to preserve. Okay? So that is going to be one of the things that we're going to work on today, is how to create materials that don't exhibit that problem, which is very, very useful when you're making materials for things like structures. If, for instance, I have a building where much of the exterior of the building is made of brick, I don't want to have to create different versions of the material for every piece that is supposed to be made of brick. I want to use the same material so that it is efficient. So let's do this now and take that material off. This mesh is selected, and I'm going to find it here in the details panel, and we're going to revert back to the default, which is basically nothing. I'll navigate back to the content directory, and now I want to share something very special with you that you may not know. There is an entity called Quixel Megascans. That's spelled Quixel, Quixel Megascans. And that used to be a company unto itself until it was acquired, actually, by Epic Games. Quixel Megascans is one of the best resources that you can obtain the things that you're going to need to make excellent world-class materials. Oops, I forgot to take it off of that mesh, so let me fix that. Okay, to make world-class materials that can appear utterly real. So if you're looking for photorealism, Quixel Bridge assets are among the best of the best. Now, here's the good news. If you are an Unreal Engine user, you have access to the entire Quixel Megascans library for free. I mean it, for free. If you're not using Unreal Engine, you can still use Quixel Megascans assets, but you'd have to pay for them. Now here's how we can access Quixel Megascans assets from within Unreal Engine. So you can follow along with me as I open the Window menu, and notice that one of the options is this thing that says Quixel Bridge. So I'm going to click on that, and that will load. Okay? And again, I usually like to dock that, like so. And I can always toggle back and forth between something that I've docked and my main map, as long as I leave my main map up there. I wouldn't want to close that tab. Okay, so here is our user interface for Quixel Bridge, and when you use it for the first time, and sometimes it will happen that you will need to sign in. Currently, I am signed in, and you can always check this if you go up here and you just click this icon. If it says sign out, it means that you're signed in and you don't need to do anything further. But if it says sign in, you are going to need to log in to this service using the same credentials that you use for Unreal. You do not need to make a new account. You do not need to make a new password or a new username or anything like that. So whatever you use to log into the Epic Marketplace or Unreal Engine, you will use those exact same credentials. This is something that you can explore because it's not just materials. It's also things like, meshes and things that you can use to build worlds out of. The trees are mostly found in the Epic Marketplace. I will tell you that. The best trees that they've got are in the Epic Marketplace. But we've got all sorts of categories, and you can really go down the rabbit hole here in looking for things. Okay, these are some of the best meshes, for example, and they do this by very advanced 3D scanning methods. So when I go for a material, then I'm going to be using textures that are very, very meticulously acquired by Quixel. So let's just go back to our home page, and what I want here is to explore this world of surfaces. Now, advanced materials are made out of what are called texture samples. And there are different types of texture samples, and texture samples are basically just photographs, square photographs of a real surface. Okay, so for example, if I look at this category of the ground, these are derived from actual photographs taken of patches of ground in different environments. And they can be absolutely photorealistic. So I'm not going to make a ground surface right now. Remember, we decided we were going to make a brick wall. So there is a brick category under surfaces, and I'm going to find brick. And there are now other subcategories of brick. Do I want modern brick, mortar, painted, or rough? And I can start narrowing it down that way. So let's look for, I don't know, how about rough brick. And we can preview the look just by clicking on something that looks like it may be something that we want to use. So these are just previews. That's a little too pretty. Rough brick wall, that's kind of nice. And, there's lots and lots of them, okay? So I think I like that one quite a lot. Now, these come in different quality levels. So while I have a surface selected here, notice that there is this menu where I can choose from low quality to medium quality to high quality to highest quality. And sometimes there's a version above that that says nanite. I would recommend that you download these in the highest quality available. And understand that sometimes highest quality, these are very high resolution textures. So highest quality here can mean 8K or even 16K. And they have themselves in quality as we step down. So even a medium quality download is, it could be a 4K texture. And if you don't have a 4K monitor, you are not going to be able to see the difference anyway. But I'm in the habit of using the highest quality available because I can always reduce it in the engine if it's becoming too computationally burdensome for my computer. So I like that one. So I'm going to select highest quality, and it looks like I already have this in my Vault cache because it says downloaded. If it didn't say downloaded, it would look different. For example, I don't think I have this one. You can see how it says download. If I click download, it will take a little time to download those assets that relate to that material. And then once it's ready, it'll say downloaded, and you can press the add button. This one I can see, and the checkbox confirms that I already have this one. So I'm merely going to select it. It confirms that it's been downloaded, and I'm going to click the add button. When I click the add button, what is supposed to happen is that a moment will go by, and it should switch me back over into my third-person map tab up here. And I find that that doesn't always happen. So if that does not happen, oh, it did. I didn't click on it, but it just took more time than I was expecting. If that doesn't happen, you might want to just click back onto that tab. So what we've got here is a MI, what's called a material instance, and I'm going to make a distinction between what are known as master materials and material instances, perhaps in this video or the next one. But I want you to notice that this has come with basically 3 assets that are called textures. Technically, these are what are known as texture maps. And these two, actually all 3 of them, started out as photographs, like I mentioned before. And all 3 of them are used together to create the final material. So let's drag this onto this surface, and you can see that that's what it looks like at the moment. But just like the problem that we had previously, this is going to be likely to deform and stretch in ways that we wouldn't want if we were to apply it to meshes that are of different scale. So let me reduce that or reset it back to the way it was. And I will reset the material as well. What you might find is that when you're downloading Quixel materials is that instead of using the one that is included, you might want to make your own out of these 3 texture samples. So we're going to be brave, we're going to take a deep breath, and we are going to utilize all 3. While we're doing that, we're going to learn some other things that are relevant to making materials. So here we go. I like to do this usually in the same folder, by the way. So I've got in content, as soon as I bring anything in from Quixel Bridge, there is going to be a Megascans folder in your content browser. I can double click that. Right now I have one folder called Surfaces because that's all I've downloaded so far. But if I had other things like 3D objects and other things, they would appear in separate folders. But right now I'm going to go back into my Surfaces and go back into my rough brick wall, and I'm going to make my own material right here within this folder. So we'll right click as we did before, and we will choose material. And I'm going to name it M_my brick wall. My brick wall. I'll double click that and dock it as I did before. Now, one nice thing, I'm gonna temporarily navigate back to my main view in our standard viewport. We are going to need all 3 of these assets in order to build out our own version of this brick wall. So by shift clicking, you can select all 3 of them together. Okay, so again, if none are selected, I can click one, and I can shift click the last one. That will get all 3. And if you ever have to make discontiguous selections, you can use the control button and make cumulative selections while skipping other selections. But in this case, that's the easiest way for me to do it. Now, what I want to do is to carefully left click and hold on any one of those 3 and drag them as a group up to the tab where my material is. When you hover there, and I'm still holding down that left mouse button, it'll take you to the material graph, and then I can simply drop these in here, okay? And I want to organize them in a specific order, okay? This is going to be used for our albedo map. And notice that it is not just a simple RGB color. That is a true texture sample. okay? A photograph, if you will. And there are 2 other texture samples here. I'll explain a little bit about what these are for. This defines our base color. I could plug that in right away if I wanted to, and I'd get part of my material. Let's actually project this onto a different type of surface, like a cube. Okay. And we also have this thing that is called a normal map. And the normal maps always have this colored appearance. Okay, so you can tell that it's a normal map. Another way that you can tell, frankly, is by clicking on it, and it will tell you usually that in the full name, let me see, Megascans for brick wall. Okay, at the very end of this file name where I'm hovering, you can see that tooltip comes up. There's an N at the end, okay, and that stands for normal or normal map. Let's see what the last character is on this one. That is D. So D stands for diffuse map. So just to make this, unfortunately, even more complicated, most of the time you can use those 3 terms interchangeably: albedo, base color, or diffuse map. Okay, diffuse map, especially when it is a texture as opposed to just one color. Okay, so let's just I like having my wires straight. So the normal map, when it's connected, you take the RGB out from there and you plug it into the normal input on the result node. That will impart something that it would not have had if it weren't for the fact that we plugged it in. And that, what it does is it gives it the ability to simulate light interactions as if these bricks, I beg your pardon, had actual geometry. Now, from a distance, it looks like a brick wall. But if we were to look at it up close, especially within our game world, we will find that it is like wallpaper. Okay? I usually like to think about materials almost like wrapping paper. You can wrap them around a gift. But ultimately, even though it's supposed to appear 3D, it is really just dead flat. So let's apply and save our material so far, and I'll demonstrate this in the world. Okay, let's put my brick wall. This is the one that I'm working on, not the one that came with the download. This is the one that I made myself using these 3 textures according to our progress so far. Okay, and I'll just put it on there. Let me slow down the camera speed here. That'll be helpful for me. If we look at this from a specific angle, you're going to notice that there is no geometry. And because there's no geometry, there's not much for light to interact with, because this might as well be a flat plane. Okay, there are no actual geometrical interstices there, nothing at all. Okay, but let me go back to the material, especially if I disconnect the normal map. Let's apply that and look at it again. Now it's going to have an even flatter appearance. Okay, so it does not look like light is interacting with this whatsoever. Okay, so let's try to fake it. I'm going to use Control L, and I'm going to change the position of my sun just to make it a little darker in here. And I'm going to use a point light from my Place Actors panel, and I'm just going to drop it in right here. Okay, let me move this up a little bit. And I'm going to adjust some settings that for now you don't have to memorize. Okay, I just want to get this casting some light on here and adjust some things. And again, I would rather you don't attempt to memorize everything that I'm doing right now, but just suffice it to say that I'm making this into a light that I can just sort of move around here and examine the light interactions on this surface. Right now, I don't see any kind of refraction or bending of light as this point light interacts with that surface. But when I recreate the normal map, or reconnect, I should say, reconnect the normal map, apply and save, you should now see it differently. Okay? Can you see what appears to be an illusion of 3D geometry in the way that the light interacts with these surfaces? Okay? The light will refract and bend as if it were real geometry. However, I do need to stress it is still dead flat. But from a distance, it's going to be looking a lot more 3D when a normal map is applied, okay? When light interacts with that. Okay, so I'm going to delete that point light, and I'm going to Control L once more and restore roughly our default lighting here. So going back to our My Brick Wall material, we have this third texture sample that you will obtain when you download something from Quixel Megascans. Now this particular texture sample is different from the other two in the sense, oops, I didn't mean to do that, beg your pardon. Doop-de-doo, didn't mean to disclose all that. This third texture sample is what's called a packed map, meaning that it really has 3 texture samples inside of it occupying the red, green, and blue channels. So if I wanted to, I could double-click this, or excuse me, I could double-click it here, and look inside. I can selectively look at the red channel, I can look at the green channel, and I can look at the blue channel, and I can see that they all contain different information. So I'm not going to use the RGB output of this to connect to anything. What I am going to do instead is I'm going to pull off and type break out, and I'm going to find breakout float 3 components. Okay, so now I've got my R value, my G value, and my B value. Now I want you to think of this as what we call an ORD map, ORD. And I'm even going to do something called commenting this out. While I've got these nodes highlighted, I can hit the letter C and create a comment sort of bubble or frame around them. And I'm going to call this ORD map. Excuse me, I pressed enter too soon. So I can, of course, just fix that in the details panel. Press enter, ORD map, okay? And if I want to drag this around, it'll take the nodes with it, okay? So ORD, what does that stand for? I will even elaborate here. O stands for ambient occlusion. Let me see, will that all fit? Maybe it won't fit. I might have to do a separate comment. ORD map, okay. So I'll make another comment bubble in just a moment, but I'll show you that on our result node, we have this pin called ambient occlusion, and that also affects how light interacts with a surface. That is the first pin, okay? The ambient occlusion information resides in the red channel of this packed texture map, okay? So this ORD map. So you can remember ORD, O is ambient occlusion. So I'll connect the red channel to my ambient occlusion. Ambient occlusion refers to, it works along, it's actually doesn't work together with the normal map in a technical sense, but it is something that is useful if you're using a normal map because it takes into consideration the spaces in between, the implied spaces in between, and it darkens them appropriately, not only according to the light, but also to the characteristics of the normal map, or actually the ambient occlusion map, which is a form of height map similar to a normal map. and causes the light to refract and bend or be hidden or more obscured depending on the direction of the light source. Okay, so we can use that. Now, ORD, R stands for roughness, and that is in the green channel. So if I'm not using a constant to control the roughness myself, and quite honestly I usually do, but I could use the one that's supplied with this ORD map, like so, and connect that to my roughness. Okay? While I'm here, I can make a couple of constants. One, because I don't want this metallic, and I don't want it shiny either, so I can use the same constant and plug that into specular. You can double dip if they're the same value. Okay? So now I've got a slightly more sophisticated material here, and this final pin has to do with something called displacement. Displacement is something that we have to separately enable in Unreal Engine, and that, if we apply it at the material level, will actually give this surface real geometry. Okay, it will make the bricks pop out and everything, and if I were to look at it carefully from the side, we would see it as if it were a real 3D model with all of the physical characteristics of brick. Now keep in mind that displacement does add a greater degree of computational burden onto your computer. So you have to think carefully about when is this important and when is this not important. I think if I'm going to be looking at brick walls from a relative distance, it's probably not that important. But if I had an extreme close-up from a particular angle, it might be. And we're going to talk about that in a future lesson, how to implement displacement. So right now, let's apply and save. And we still have a good-looking brick wall here. All right, so I can get far away from it, and I would not know necessarily, especially, again, if I had a light interacting with this. I wouldn't necessarily assume that that wasn't fully 3D, okay? It's just got a basic flat surface. But light is interacting with it in the way that it would as if it were 3D because of the combination of the normal map and also the ambient occlusion in our packed ORD map. So I'll delete the light, and I will teach you one more thing for today. We still have this problem, though, of the stretching and squishing, okay? If I wanted to resize this or use the same material on different meshes that have different scale, then it's going to be a problem, okay? So look at it on the ramp, look at it on the floor, okay? The scaling is completely inappropriate. So we're going to undo both of those. Now I'm going to go back to my material, my brick wall. In fact, I'm going to drag it off here for a moment so that we can see something. You're going to notice, I'll resize this, that every texture sample, just move over so you can see the wall also, each texture sample has an input here that says UVs. Now, that is a coordinate system, sort of like a vertical and horizontal coordinate system, that defines how this texture is going to be tiled across a surface. And there are different ways to manipulate this. One way is to use what's called a texture coordinate node. Actually, I could just type COORD until I find texture coordinate. See, these search fields are very useful because even if you forget the name of something and only remember a part of the name, oftentimes you'll be able to find it. So I need this thing called a texture coordinate. And if I disclose this, what I can see is the U tiling value and the V tiling value. So let me plug this into the UV input of all three texture samples because we want them to align with each other. Now it's counterintuitive. You'll see that if I increase the UV tiling, and I'm going to have to set values for both of these, So let's try something here. We've got the texture coordinate with its UV outputs feeding the UV input pins on all of our samples. So what if I were to increase both of these to a larger number? How about the number 4, so that it's uniform, and then I apply it? Notice that the texture gets smaller to the eye. And that's counterintuitive, right? The bigger the number, you'd expect the texture to get bigger, not smaller. But effectively, when you are increasing the UV values, basically you are telling it how many times it should tile this square-shaped texture sample on the surface that it's been applied to. So this is something that is very, very commonly used in ordinary material texturing. Where you just set the UVs the way that you want them, and if it's applied to just only one object, that may be okay. But if I want to apply this material to several objects and have the scale remain the same, we have to take a more advanced approach. So I'm going to take a chance, and we are going to do a slightly more advanced version of this in order to make that possible. So we're going to dock that again, and we are not going to use this method of using texture coordinates and UV values. So I'm going to highlight this node and simply delete it. Bear in mind, this is the usual way that this is done. And likewise, if I make these into fractional numbers, the texture will get larger in appearance. But for what we're about to do, I'm not going to do it this way. We're going to hit delete. Okay? So what we're about to do now is something that a lot of folks don't know about. It goes by a couple of names. It's called triplanar projection. And it's also called, in Unreal Engine, creating a world-aligned material. When I create a world-aligned material and adjust the scale of that material, the size of the mesh that I apply it to will not matter. Okay? It's always going to be the same size, and we are going to be able to control that ourselves. So let's say you've gotten this far, and you've deleted that texture coordinate node. Let's change this over into a world-aligned texture. Okay, so I'll disconnect for now everything from the result node. So we just have, let's say, these items. So we just have the three texture samples that we started with. All right, now to do this, we have to make some changes to these 3 nodes. And it's easy to do. All you have to do is right-click near the title bar, and that's just so you don't accidentally change anything below there. You can really click probably anywhere on the node. Right-click, I should say. Use your right mouse button, and then choose this option under Node Actions, Convert to Texture Object, like that. Do that for all 3. Convert to Texture Object, and convert to texture object. Okay, great. Now notice that I don't have RGB out on this anymore, and I can pull off of this pin if I were to try to use break, out, float, 3 components like I did before. I can't get that. But what I can do is I can get texture size. Did I spell that right? Hold on a second. I might have to find it. Okay, texture property. Okay, yeah, that's what I was looking for. Texture property. And in the drop down, it defaults to texture size. So that's what I need. And then from there, because these are going to be scaled in a way that is different from UVs in just a moment, from there, I can break, out, float 3 components. Just one extra step. Okay? So that has to be in there like that. Now I'll move this over, and I'll move this over as well. Try to keep things looking kind of neat. And some stuff is going to go in between those texture objects and this final result node. The first node we need, by right-clicking, is called a world-aligned texture. And you don't have to type spaces when you're searching for this. World aligned. And if you just type that much, I'm sure you're going to find it popping up in the list rather quickly. World aligned texture. Okay, so we've got one of these, but I also need one for this bottom. So I can copy and paste, or I could search again, or my favorite shortcut, if I have a node and I need a duplicate of it, is to have it highlighted and then just use Control-D and I'll get a copy. So I need one down here, and I need one up here. I need something for the normal map as well, except it's a world-aligned normal. So we're going to search world-aligned again, and instead use world-aligned normal for the middle one. And that is practically the same in appearance. In fact, I'll get these closer to where they have to be connected. A little bit easier to see. Okay, so the texture object output goes into the texture object input on each of these world-aligned nodes. Okay, so it's going to go like so, and come to think of it, I probably don't even need this because I can break this. So I'm going to get rid of that breakout float 3. I'm going to get rid of both of these nodes, in fact. That is going to be a lot more straightforward. That'll go into the texture input here. I bet I can break the outfloat 3 constant from here. Break outfloat. Yep. Components. I shouldn't have said constants. Okay, good. I now have access to my ORD once again. And the comments box, the comment box is just way too big, so I can resize that if I wish. I just left that there as a reminder for you. Okay, so I've got now my ambient occlusion, roughness, and displacement again is going to be used in a future lesson. Okay. Now, as far as adjusting the size of these textures, notice that it does not have anything that says UVs anywhere, but instead it says V3, and that stands for constant vector or constant 3 vector. I bet you remember the shortcut. I'm holding down the number 3 and left clicking. Okay? Now, when I imported this texture, there is something that I did that you don't know about. In Quixel Bridge, when I imported it, I took note of this texture size. And this is 2 by 2 meters. Unreal uses the metric system. 1 Unreal unit is a centimeter. Okay, so this is 2 by 2 meters. Okay, and if I want to make my material exactly the same scale as the real thing itself that the scan was obtained from, what I can do is I can, in my vector 3, I can just type those values, 200, and I'm going to do it in all 3 fields, 200 and 200. But I might need to artistically adjust that if I want them bigger or smaller. And the way that I can do that is I can take the RGB output and do just a little tiny bit of math, okay? There is math involved in making materials sometimes, but this I think is going to be easy math. If I pull off of that pin, I can type multiply. Multiply. Just want an ordinary multiply node that looks just like that. Next, I want to multiply this by some value that I can adjust. Now for that I could use a constant, like holding down 1 and plugging that in and entering a value. But what I really want is the equivalent of that, but something that's meant to be adjusted, and that's called a scalar parameter. okay? And that is going to give me the same thing and offer me the opportunity to name it. So I'm going to call it texture size, okay? Now, I have to be careful. I don't want this to be defaulting to 0, because if I multiply anything by 0, then the output is 0. So if I type 1 as the default, that means that I'm getting the default texture size that was obtained by looking here, 200 by 200 by 200 centimeters, okay? So I will connect that to the texture size pin on all 3 of these world-aligned nodes, texture size, okay? And now I can take the XYZ texture out of this first world-aligned texture, plug that into the base color, take the XYZ texture out of the normal map, plug that into the normal, and then use ORD. O, ambient occlusion, R is roughness, and then maybe I'll just make some scalar parameters for metallic and specular. So I'll pull off of here and I'll type scalar, and we'll call it metallic. It's the same thing as a constant, but you can adjust it in a special way that I'll show you in just a moment. I'll pull off specular, and I'll type scalar, get a scalar parameter for that, and I'll type specular. I'm not even going to bother setting these values just now. And there are other parameters that we're not going to worry about for the time being. Okay, so it's not metallic and it's not shiny, and the roughness is coming from the roughness map that's inside of this packed map. All right, out of the green channel. Okay, so now this is basically ready to be used. Let me just move some of this stuff closer just to make it look nicer. And we're going to apply and save. Now, let's go back to our map, and you can see our my brick wall once again, okay? And if I were to apply that, it's not going to look any different because I haven't really changed anything yet. So what I will do is right-click this, and I'm going to create what's called a material instance. Material instances are what you will be applying as materials much more often because you can parameterize them and visualize the changes as you're making them, okay, rather than having to hit apply and save every time. So what we'll do is we'll right-click this my brick wall, we'll consider that the master material, right-click that, and then we'll simply choose Create Material Instance. And it adds INST at the end, but I also like to include MI at the beginning because that's the standard convention for material instance. You can even see that here on the Quixel material that was originally downloaded. So we'll do that. I'm going to save it, and I will apply that. Still, nothing should look different, but I can now open this material instance. Let's undock it while we look at that brick wall. All of the things that we turned into scalar parameters can be enabled and manipulated here now. So let's go for the texture size first. Notice that as I manipulate this value, I can make the bricks smaller, I can make the bricks larger, whatever I want, okay? If I don't like the default setting, if for artistic reasons I want to change that, I can do it in real time. If I want to change the metallic and specular values, I can do that also. I don't think this is going to be very shiny unless there's a light in front of it, but I could do that as well, okay? Maybe I'll put a point light here and see if, or not a point light. Yeah, a point light, sure, why not? You just change a couple of settings. Get this point light, and see if those metallic and specular values are actually responding. Yeah, they are. Okay, so you can add those yourselves and make as many parameters as you like, okay? So let's suppose that I want these bricks to be their default size. Well, that would be 1. But if I wanted them to be twice as large, what would I do? Could it be 0.5? Let's try that. Nope. Now it's intuitive. So I would say 2, and now I've got double the size. If I want to double it again, well, I would set it to 4, and so forth. But I liked it at 1 or close to 1. That was true to life anyway. I don't need this light, and I can turn off the metallic and specular because I'm just not using those. And I can get rid of this light. Okay? So now we've got a world-aligned or triplanar material. Now here is the major advantage of this. This is what I was leading to all along. If I want other things to be made out of this material, let me save my material instance, I can put it on anything. And the scale just doesn't change. Okay? Anything that I want to be made out of brick is going to have the same texture size. And if I have a mesh and I choose to scale that mesh, notice that it maintains that texture size. That would be impossible if we were relying on UV manipulation only, okay? This is an advanced technique. I'm not going to lie to you, but you should congratulate yourself if you've gotten this far. You have created a world-aligned texture and a material instance that you can use on any mesh that you like while keeping the scale of your textures proportional to the size that you want them to be. So with that, I'm going to end this lesson and have some fun, explore the Quixel Bridge site, download some materials, make your own triplanar materials, experiment with UV manipulation as opposed to world-aligned coordinates and things like that. But this is very cool because now any brick wall is the same as any other brick wall, right? So that's very, very handy, especially for things that have to look like they're made out of the same stuff, okay? I hope you enjoyed this, and thank you for sticking around. This was a long one, so just keep up the good work, and don't forget to have fun. See you next time. Bye-bye.